Okay, let's start. Welcome everyone, and to another advanced training course today. Let's directly jump into the organization topics. First things first, the training will be recorded, and you will get access after. Sometimes it takes a little bit to share the video because it has to be cut and so on. So yes, but you will get access. To my person, my name is Kuemmel. I'm a senior Java developer, project manager. I'm involved in some projects, mostly with EclipseStore and cluster and so on, within the Allianz and also on Fraport, German airport. And I'm a project lead of the MicroStream or EclipseStore cluster development. Sometimes I'm also trainer and conference speaker, and that's also the reason why I'm here for today and guide you through the training. So let's move on. So this is the timetable for today. So we started at 5, around that. Then we go till 6:30 around. Then we will have a short break for around 50 minutes. And then we have some further lessons until 9 p.m. For some Q&A. There are a lot of topics I prepared, and but I will go through it a little bit later. Just at the beginning, let's talk about the material or the stuff you will get. As I already mentioned, the session will be recorded, and you will get access. And you will also get access to all the code repositories and demos of that project, and I will share this with you. Whenever a new topic starts and whenever we're talking about a new topic, then mostly I prepared a project on this, and then I will share you the URL of my repository, and that enables you to code along with me in some topics if you want. So feel free to code along with me. So mostly, not all of the topics are live coding, but most of them you will be able to check the project out and start it on your side for some further or advanced questions on your side. So regarding the links, there are a lot of, and these links I will also share it with via the chat. So give me just a second. Let's do this. So just copy paste this to the chat. Here we are. So these are all the links you will need to understand what's going on in the training for today. So the first 3 links are the most important EclipseStore GitHub repositories. Another one, the EclipseStore documentation. Sometimes we will also look into the documentation for some further informations, and then there are a lot of trainings examples, and exactly these are the examples we work on that are part of my GitHub repository. This is the last link of that page here. So, and whenever we start a topic, as I mentioned, I will share this URL with you. And of course, you will get a certificate around 5 or 6 days after the training. Sometimes it takes a little bit longer. So like the last certificate, because it was during the holiday season, and so it took longer than expected, but normally it takes around 5 to 6 days after the training. Then you will find a certificate within our cloud environment. So that means when you register there with the same email address you registered to the training. So just a second, and I can share this with you. Moment. This should be the right one. So yeah, you have to register to the URL cloud.microstream.1, and then you will find a certification section on the left here, and then you will see your certificate here, and you should be able to see a certificate like this. But the important thing is, as I mentioned, you have to register with the same email address you used for signing up to that training, and then the mapping will work. And if there are any issues, or if you need a different email address, just let me know. You could write down this in the comments or send me an email, That brings me to my email address. I will also write this directly to the chat. Oh, this one, here we go. Yes, this should be the right one. c.kuemmel@microstream.one. Do not forget the one at the end. It's not com or something else. It's just one. Okay, so let's move on. And now we are at the topics for today, and there are a lot of topics. So at the beginning, we always start with a small project exercise, warm-up project. Yeah, just to, yeah, as I said, to warm up in all the coding stuff. It's also a warm up for me to show you CRUD operations, EclipseStore configuration, and so on. And then we are going through some configuration details. It's an advanced training, so we will have a look to different situations. It's how to configure an S3 bucket, for example. Then we go into the Micronaut integration, how to use EclipseStore within Micronaut or Spring. Then I will show some different possibilities to configure EclipseStore, and also the housekeeping is a topic that you need to know, channel configuration and so on. The more advanced stuff. Yeah? It's not that big deal, I have to say, but it's important to know this and to know how to configure this. Then it goes into, also, let's say a smaller topic. It's storing advanced, not only using just the store method to do things. There are other things to know, like what is the difference between eager and lazy storing. Sometimes I explained that already in the fundamentals training, but for some of you this might be also interesting. So the differences between lazy and eager. So what does it mean when we talk about transaction, rollback, and exception handling? Sometimes that makes sense that you know this. A new topic for that training is the gigamap handling. So I prepared a totally new project for you with an example, with a complete example about how to use the gigamap with the new version 3.0 now. So it's out now. So, and it's also included and available for you. And I prepared some bitmap indices and also a Lucene index, and we will go through that project, and you will get access, and we will have a look into this, how this works. And I promise you, that works really great. I prepared this today for you. Then last but not least, or not last, but a more core topic is the concurrency handling. It's always an important topic, especially with EclipseStore, because we all are working on a single object graph, I have to say, and then it's important to know how the concurrency handling is working here. Then we also have to talk about LegacyTypeMapping. That means what happened if my Java classes changes, how to handle this within EclipseStore. Housekeeping, I already talked about this, and now this is the last topic, how to backup with EclipseStore, how to use the backup functionality, what is best practice, and so on. I think that's an interesting topic as well. Okay, so any questions so far regarding the topics? Is there anything you need to know? Maybe you missed the lazy loading topic. It is normally lazy loading was included in the advanced topic, but we already talked about this in the fundamental. So if there are any questions regarding lazy loading, let me know. It will be possible to step into, or if you want, maybe you want to skip, then we have to a specific topic, then we also have to talk about this. Okay. Let me summarize the EclipseStore technology a little bit, just for the new participants of the training. So EclipseStore is, as always, is a Java framework, of course, with an included from scratch invented object graph serialization. So that means we are not using the Java serialization in the backend. It's a new invented way to serialize data. With that framework, we are able to serialize data to the most known file systems. So that means to the file system, of course, and also to AWS S3, Kafka, some relational databases. So we take care about storing data to that systems. And we are also able to update this, but I would say storing things somewhere and also updating things somewhere is not really a big thing. The interesting part is that we are able to update these serialized things partially. That means when you store a huge object graph, you will be able to update single elements, single nodes without storing the whole serialized part again and again. We are take care about that data mapping, but there is no data mapping necessary anymore. So that means we do not have some special data structures like all the other databases. There is no relational models in between or some OR mapping in between. We are using the objects as they are. We are just using the pure POJOs. Okay, so that's it for the start, and that brings me to our first example. So, and that example, I'd like to share this with you directly. So feel free to code along with me. So let me just share the link to the project. Just check where you are. Here is it. Exercise. Okay, that's our first project I'd like to share with you. Feel free to check it out. There are two branches. One is the master branch, which is already done, I have to say. Check it out, start it, and this will work. And there is a second one, which is called start exercise here. And surprise, this is where we're gonna start. So let me just check. So I prepared the project here. So let me switch to that start exercise here branch. And regarding the project itself, most of my, or all of them, I have to say, all of them are based on Micronaut. Micronaut is in the same way a microservice framework like Spring Boot or something else, and they are working very similar. When you check out the project, you have to ensure that your annotation processing is activated in your IDE. So on the Eclipse IDE, you will find that setting within the Maven section. There is one part which is called, as I said, annotation processing, and this needs to be activated. So in my case, automatically or experimental, that both will work, but this needs to be activated, and then the project is quite easy to use. There are two different possibilities how to start such a project. So first, you have that application class here. In every Micronaut project, you will have this. You could do it like this. So let's say run as Java application, and then you should see the console or the terminal like this. And it says, okay, application is started on localhost 8080. And then you know, okay, mostly you are good to go. Application is working as expected. Another point to start such an application is, let me just check. So when we use the car exercise here, right click and then show in terminal. And then you could also start it with the Maven console and say Maven mn run like this. And this will also start the project. Two ways. I think there are 1,000 more on different IDEs, but just to let you know, this is the way how to start the project and the examples. As I said, give it a try. It's on you to how to follow the course. Okay, So I'm on the right branch. Are there any questions so far that I missed? Maybe Marcus already answered some of them. There is one question: is there an example of how to run as a dedicated data storage? Yes, that's exactly what we will do here. A dedicated storage, so let's say as a storage service or whatever. This is exactly what we will build here. It's a, as I said, micro application. It provides REST endpoints to get the data, store the data, and provide the data to many other consumers, I have to say. So let's move on. We will start on a special class, which is called the DB class. This is the static class where we will initialize our database. Mostly I will use it this way. I will show you different approaches of how to initialize EclipseStore, because so with such a DB class, this is normally not the way to go within Micronauts. So because we are talking about object bean injection and so on, and we do not want to have such a static content, but to keep the training as easy as possible, I will just do it this way. And yeah, for those of you who want to do it differently, feel free to do it. And I will also share you examples how to do it. Okay, so we are in that DB class. And as I said, this is our database initializer. And there are two different or two most important objects that you want to have within an application. And this is the embedded storage manager. And this is one root class. The embedded storage manager, and that brings me to the POM XML. So let me just share the POM XML with you. That's also an important point. Yeah, you will find it here. So this is the newest version 3.0. And normally you need the storage embedded. This is the main part, and there is a second dependency for the configuration part. So that provides you the embedded storage configuration builder pattern, and that's why we have this in our project. That's all you need to get EclipseStore working. So this is already there, and then we are able to start with the initialization of our database manager, I will call it. So, and this is the embedded storage manager. This is the storage manager that takes care about synchronizing things and serializing things to your hard disk. Storage manager. Okay, this is one instance that we need. And as I said, we need a second one, which is the root entry point of the object graph. So we always talking about graphs, and when we talking about our graphs here in the project, so you see that within the domain package there are already existing domain classes here. Most important, car and brand. So each car could have a brand or whatever, and there is a company itself, and the company holds all the underlying object within collections. So we have one string name for our company. And the company consists of a list of brands and also a list of cars. And when we go deeper into cars, we will see that a car consists of the model itself and a brand. So that means the hierarchy is somehow company, cars, and brands, right? So this is what we have. And therefore, our entry point to the graph is our company object. And that's the reason why we will use the company itself or an instance of a company as a root entrance point. So let's initialize our root object. Let's say public final static company equals, and let's call it root to make it more understandable for you. So that's the entrance point, as I said. and let's say new company. Okay, we need to import the company, and that's it. So that's so okay, great. Okay, so let me just send the GitHub link again. So yeah, as I said, feel free to check it out. This is the example that we are currently working on. Okay, so we have the root entrance point, we have the storage manager, and now we need to initialize both. So let's create a static block here. And yeah, to initialize. And this is the point where we need to initialize our storage manager. So storage manager equals, and then we're using that configuration pattern. So we need embedded storage configuration, and it provides a builder pattern that is mostly used. And yeah, normally, as I said, this is the most, yeah, from my side, I will always recommend to initialize the storage in this way. It provides all the possibilities or all the power to configure your storage, and that therefore I start with the set channel count, and we want to have a channel count of 2, and I will use that situation here directly to explain what the channels are or what the channels for. So when we mostly storing things directly to the hard disk, and therefore sometimes we especially when we're talking about storing bigger binary files, for example, to the hard disk, it makes sense to have multiple packages to store in. So that means having multiple writer threads to your hard disk, and therefore we need multiple channels. The channel count could be 1, 2, always power of 2. So 1, 2, 4, 8, and so on. 16, and that enables you to write down data in a multi-threaded way to your hard disk. So that means when you know, okay, you have to store a lot of bigger binary files, that it could make sense to have multiple channels. And I would recommend a sweet spot always something between 2 and 4. That's, in my opinion, totally enough. You could have 8 or 16 or whatever. It's totally on you. You just have to try it out, how the performance works, because the more channels you have, the more your data is separated, I have to say, and yeah, sometimes that is that ends up in a not the best performance, I have to say. Okay, set channel count 2, that's enough for us. Then we need to set the storage directory. So this is the path where we need where we want to store the data. So therefore we using just using the data folder. And based on this, we are totally good to go and say create an embedded storage foundation. I'm pretty sure most of you already created stuff like this. And a foundation, let's say, is the underlying layer of an instance. And based on a foundation, we are able to create an embedded storage manager. And the storage manager gets the root object, that the storage manager knows where to start or what is the entrance point to read the files and also the structure on the database. And then we call a start method. This is very important. Sometimes I forgot that start, and I'm wondering why is it not storing data, and some other issues happened without that start. It's really important to call that start method at the end. Okay, and that's all we have. So we have a static block here, or a static, a static initialization. As I already mentioned, it's not best practice within Micronaut or in other microservice frameworks. But for now, to keep it clean and simple and make it more explainable to you, I will do it this way. Okay, so we are good here in that class. Now we have to go on and check the domain classes if everything is in place. So I already checked this. So we have the company object with string name, brands, and cars. It's a normal data structure. that we have all the day. So it's just pure Java without any special annotations or something. We don't need that stuff anymore. So then we have cars. Car, for example, it consists of model and brand already in place. And we just have to check the brand itself. It only consists of a name, right? So that's what we have. Some of you might wonder, because why we do have a list of brands here where we want to store. And on top of that, we have each car has its own brand in it. So some of you might say that does this doubles the RAM? Just remember, EclipseStore is an in-memory database. So that means most of the data or without special settings, all of the data stays in memory all the time. But yeah, it not doubles the data, because a brand is just a reference. It's all just a reference in Java, and that's why. But why do we need a separated full list of brands, and why can't we? Why is it not enough to have the brand within the car? Well, you always have to consider that. Let's say when you remove the last car of a specific brand, let's say there is only one BMW left in your list, for example, and you remove that, then you will also lose that brand. So that means when you want to provide a combo box for choosing a brand or whatever, you need always a full list of brands. And then it could make sense to have a list of brands just for filling up your combo boxes or value choosers or whatever. And then you could add it to your car. But yeah, as I said, when you delete a car with a last reference to, let's say, BMW, for example, then you will lose that brand. And that's the reason why. Okay, so let's move on. So there are two controller classes. I want to jump in. And I would say let's start directly on the car controller here. Here we are. So I created a lot of different controller or interfaces. Let's start with the list cars. So, and we just want to return all the existing cars in my database. And this is quite easy to use. We need our DB class, and we say db.root. So, and therefore we are on the company level now. And then we could say get cars. And that's all we need for the first interface. And this is, by the way, that's the first point that enables us to try it out if this is working as expected. There is another clean cars. No, we are not able to store something. So let's wait a little bit. But we should get an empty result. So that could be checked. So just try it out to start the application at this point. And as I said, you should get the message localhost running on localhost 8080, and I will do the same on my second screen now. So I will call localhost 8080, and car controller is /cars. And that should do the trick. And you should see EclipseStore is initializing successfully here. And this is because I've called the DB method or the DB class here and the root here that initialized the static content that we created. And you should see a result that looks like this, just an empty result on that cars that we have here. Okay. Any questions so far? So many channels we have, it would take longer to finalize the startup process. Not really, because it's more on the amount of data you want to have within the memory. So let's say you have 1 terabyte or 1 terabyte of data on your hard disk, and none of them are lazy loaded. Then you have to load, of course, 1 terabyte to the RAM at startup. So this is basically how it works. And I would say it doesn't matter if we have 1 channels or 2 or 4 or whatever. we could load this in a multi-threaded way to the RAM. Yeah, it will speed up the process a little bit, but you have to load this anyway. But it's more to, yeah, you are right in a way that we could in parallel load the data, of course, because we are able to access multi-threaded to your hard disk. Okay, so let's move on. Let's check. Some of you might say, okay, how to get the data back. So cars by model, for example, and that brings me to the how to query data. That's why I'm doing this. So we need access to our DB class again. So let's say db.root.getCars. Oh, sorry, get cars. And then our streams API comes into play. So let's say stream.filter. This is also how we normally access the data and how we filter the data. And let's say car, car.get. What do we want to have? Model. So get model dot equals ignore case. And then we could add model. So we need to collect the result. So let's collect collectors to list. To list. Does it work? Exactly. So yeah, let me. We are. Okay, so here we are. So that's how it works, how it works to access the data. So we, as I said, we are using the streams API. So we're accessing the cars collection, then we say stream, and we use the filter keyword here. We filter for car, get model equals ignore case. Model itself. Model is the point that we hand over here within that interface. And after that, we need to collect and we want to return a list. And this is what we have here. That is working the same way here by cars by brand. It's working exactly the same. Let's do so. db.root. It's always the same way how to access the data. But in this case, we want to access the cars by brand. So we are getting cars.stream .filter. Well, let's do it directly. .filter. So car again. Then we need car.getBrand.getName equals ignore case brand. And we have to collect it again and say dot collect collectors to list. That's it, and nothing more to say about this. I would say it's the easiest way to filter for data. It's getting more complicated when we're talking about the GigaMap a little bit, but this is really straightforward and, in my opinion, much better than any SQL or Streams API provides all that we need to search within the data, and that's easy to use, I have to say. Okay, so to clear all cars or to delete cars, so let's check it out, what we need. So first of all, we need to db.root.getCars. And guess what? It's quite easy. We are calling the clear method. So, and we have to do this without the return. So, okay. So that's the first step. So first we have to clear, and then we have to store it, right? So we at this moment we cleared the collection within our RAM, and to let EclipseStore know how what happens on the RAM and what needs to be persisted to the storage itself, then we need to call the store method. That's the first time we need that store method, and whenever we want to store something, we need our store manager. db.storemanager dot, and then we say store. And the question what to store is we need to store the thing that has changed. So, and this is always an important thing with EclipseStore. You always have to store the thing that has changed. And of course, we cleared the cars, that's for sure. But in fact, we just changed the collection that holds all the references of cars. And this is the reason why we have to store the collection get cars, right? So that's how it works. So that means the collection of cars has changed because we removed some of them or all of them, and then we need to return something. And that's also the reason why we call it here store, and we hand over that collection. And last but not least, we have to return something. Let's do this, the HTTP response. This is just on top. Let's say okay, and okay, here we are. So yeah, cars cleared successfully, whatever. So it's just a message. So, and our last example is an insert car example, a more advanced example, but let's go through this. First, before we could add something, we need to check if a specific branch or brand is already there. And I will copy paste the first part of that example. So the first step we need is we have to check for an optional brand, for example. So we first have to check if the brand of a specific car that is handovered is already there, and therefore we filter for such a brand. So it's the same stream that we used above here in that example here. And okay, so find first we have an optional brand. So if that brand is let's say optional brand is present, I guess, yes. So if it's present, then we could go on. So then we need that brand. So we say optional brand.get. So that's how it works. And let's assign this to an existing, to a brand itself. And now we could create our car. So let's say new car. So we have to also assign this to a car and then say car.setBrand and car.setModel. And therefore I have to say is there anything that I missed? Set model, did you all get model? That should, oh, what is this? Public car insert. What did I miss here? Post insert should look like this. Ah, okay, something is going wrong here. So, okay, so now this looks good. Okay, so we have a car, the data transfer object, and then we have to store that car, of course. And how to store or insert something is works the same way. Then, so we need our get cars collection, and on that collection we could say .add that car. And then we have, of course, we have to store it. And it, as I said, it works the same way. So that means we could copy paste this from above. So we have the DB storage manager store. And of course, we changed the collection because we added something to that collection. And that's why we need to store the collection, because it has changed. And that's it. So last but not least, we have to return something. Return car, I guess, doesn't matter. It's just an example, just for you to know how it basically works. And that tells us, okay, we are good to go with that class here. So that means we added the possibility to show us all the added cars. Then we have the possibility to search within Eclipse Store and do something here. We have to delete, or we are able to delete something, and we are able to insert. And so that covers all the different CRUD operations that we need within a database. And that makes, yeah, I have to say, out of the cache, what Eclipse Store is also represents also a persistence and also an in-memory database, I have to say. Okay, so we need to do this also in the brand controller. There are only two interfaces that needs to be filled, and just to speed things up a little bit, I prepared, of course, this. So let me copy paste this, and it's mostly it is mostly the same. I just need to import something. So let's say db. Okay, here we are. And as I said, it's the same on the brand side here. So just copy paste this from GitHub. Optional, I need to import this. Okay, here we are. So, and that's it for the warm-up project. So just we need to give it a try if this is working as expected. So I prepared a small example, or I also created the car exercise in my Postman here. And so give me just a second. Save this. Do not need this anymore. Okay, so cars by model, insert a car. This is needed. Insert a brand. This is also needed. Okay, so insert a brand, insert a car, all cars. Okay, so here we are. So let's start with all cars. Let's, oh, is it? No, we have to start this. Let's start the application, run as Java application. And we see, okay, up and running on localhost 8080. So let's check if, so we are getting the same empty result, and that brings us to the first. Let's insert some brands. So there is, of course, we need an Audi as brand. So send this, and then we want BMW, and let's choose a Ford also, and Mazda, whatever. So then so we have 4 brands, and let's insert a car now. So an 8A, A8. So for Audi, let's insert it. So we're getting a 200. Okay. Then let's do an A6. Send. Then we need an M3. That's a BMW. And last but not least, a CX5, for example, and that should be Mazda, right? So, okay, so let's check the cars. And you see we're getting the result. Data is there and is stored. And when we now restart the application, so let's turn it off and start it again, we should see the same result, right? So this is what we expect. So when we now is up and running, and then we send it, and as I promised, now we are seeing the same result. This is how it should work. Okay, so any questions from your side? So the first part is done. So we walked through our warm-up project. Let me just check your questions. In relation to that, whatever you can use with plain Java, you can set its framework and feel free to use it. Exactly. Yeah, that's a good point. As I said, so at this point here, this is a good example. So as I said, this is a Micronaut project here. but there is nothing related to Micronaut. This is and this is also the reason why I used that static initialization. I know this is not best practice, of course, but this gives you an idea that you can use EclipseStore on every other Java-based application, whatever it is. It could be Spring or whatever else. So feel free to use it. The only thing is for the version 3.0, you need Java 17 is the lowest supported Java version. But except of this, use it whatever you want. Milos, of course I can. So can you answer a question above about wrapping with lazy? So of course, let me just scroll up a little bit. I need to find, here we are. As well, try myself. What happened if I don't store anything lazily at first? Then I get an idea that something might in fact be stored lazily. Can I just wrap the object with lazy? I need to understand what happens if I don't store anything lazily at first, and then I get, okay. Yeah, this is kind of like a migration, I have to say. So that means I would recommend doing it this way, creating a second object or a second collection, and migrate the data from the previous version to the new collection and store it. And at that moment, everything is up to date on the second collection. You will be able to delete the first one. Maybe this is, I have to say, this is this is kind of like a big migration, but it is working like this. Just create a second collection and then move the data, and then everything should be all right. Another question that whatever, there is one catch with Quarkus, Spring Boot, it's the same as Milo said. Is it possible to have two separate app instances targeting to the same stateful storage? Always the same question, but an important one. It is not. So it's, I would say it's basically possible, but not at a time. So that's important, because there are, even when you start EclipseStore, there is a possibility to start EclipseStore in a kind of like a read-only mode. So this is possible, but in the background there are working some housekeeping processes and so on, and they are doing stuff on that. So it's basically not possible. If you really need a solution like this, then you have to use our data replication tooling. I mean, I would expect the reason for your question is to create multiple instances that answers someone. And this is, by the way, also the use cases for our new upcoming cell storage. So we are currently working on the cell storage, and that cell storage, this storage will work the same way you expect. But for this one, you have to use data replication to have multiple instances. But except from this, it's not possible to access one storage from multiple instances. And by the way, this could lead to a quite horrible damage your storage, because if two applications at the same time, I mean, we prevented the storage doing this. There is a lock within the storage to prevent two applications to access at the same time. But yeah, as I said, you never know what could happen. And there are some situations, especially when we're talking about Kubernetes and Docker and so on. Some of our customers tried to use the clone functionality of an persistent volume, for example. At the same moment, the storage writes data to the storage itself, and that this leads to big issues within the storage. So you should always be careful with that. Could you show the postman request storing the brand again? Okay, of course. So So these are the three endpoints. So insert a brand or insert a car. So let's start with this. So I could share the body with you. That makes it a little bit easier for you to create an endpoint like this. That's the body. It's a post. Insert brand, it's the same. And all cars, yeah, it's really straightforward. It's nothing special here. Okay, another question, but isn't Eclipse Data Grid Cluster a distributed storage for microservice architecture so you can have as many instances as you need? Yeah, exactly. That is what we plan. The idea is, so when we just to go into this a little bit, when we're talking about the Eclipse Data Grid, then the data grid itself, it's more an infrastructure or an out-of-the-box infrastructure for you to deploy your data provider projects into that, and the infrastructure in the background handles the replication of your application. So that means at the beginning, when you start with EclipseStore, feel free to start exactly this way and see how it behaves and how it performs. And I will promise you, an application or data provider like this performs 100 times faster and more memory efficient than any other solution on the market. So believe me, normally I provide a performance demonstration of that, but we have to go on. And start with an application like this and check it out, how it performs, and feel free to say, okay, it's totally enough for me to have this. But in case of, let's say, failover scenarios and so on, I understand that sometimes you need a second pod or something. Then you could create such an environment on our SaaS cluster, and then you could provide us your application in the same way you created here with some slightly different changes. For example, you have to change the embedded storage manager here, this one, and you have to change it to the cluster storage manager. And this enables you to provide us the application, and we are doing the replication for you in the background, and then you will get replicated instances, and you could have up to, I don't know, 10 or more replicated instances, and yeah, replication is happening in the background and so on. This is how it works. So the data grid is more an environment that can run in the background, and you provide an application like this, what we created now, for storing data. And by the way, that environment I've talked is not only available via SaaS, it's also available on premise, and therefore we providing our Helm charts and so on. That is part of the data grid. So I think that explains that a little bit, the differences between EclipseStore as a framework and the data grid is more the environment to provide your application at the end. Okay, so exactly, there is one write instance and multiple read only instances. Yeah, exactly. This is how it works. Not a second read only. It's a yeah, but maybe yeah. When it comes to the data grid, then the data grid has one single master node. It's the writer node, and multiple. It depends on you, reader nodes. That's how the data grid works. Okay, so if there are further questions, just let me know, and during the time I will go on with the next topic. But I have to check. So sometimes. Okay, here we are. Okay, so let's move on with the topic configuration advanced. So I brought another project with me. So let me check. Yeah, this one here. So it's called MicroStream configuration. Let me check if there are multiple branches that could be helpful for us. So property finance, yes, there is. Okay, so first I have to share with you the repository. MicroStream configuration. Where is it? Need to search for. Here we are. Okay. So as I said, this is not a hands-on example. It's a pre-created one. That is the project here. It is called MicroStream configuration, and there is one branch we want to directly step in. It's the configuration done branch. So and within that branch, there is one. When we jump into the DB class, yeah, here we are. And then we see different instantiation or different possibilities of instantiate a data root and a storage manager. And in that case, I created 3 or 4 embedded storage managers. That also answers the question if you are able to have multiple ones. Because in the past, there are some questions regarding, can we have multiple roots in one storage? And I think that example tells you multiple roots is not possible, but you could have multiple storage managers. And therefore, this is, I have to say, it's the same. And it's we see that here there is a short storage, or I called it the short storage. This is a short way to initialize EclipseStore just with embed storage.start. You hand over the root and you need a path. And then that's all, and you are good to go. Another one is initialize the storage via an XML file. In that case, I provided a MicroStream XML file down here. It contains all the different properties that you want to have, let's say a channel count of 4, and also the storage directory. This will also work. This line of code here is, it's directly related to Micronaut. It's not part of EclipseStore, but it provides you the XML file, and then you will be able to use that file here to load the resource, get the path, and then that's the way how to initialize. So this is the already known initialization, the builder pattern. So we already talked about this. And another one, which is a more, I have to say, complicated one, and but it's no longer used. So I mean, it's the direct usage of the API, of the inner API of EclipseStore. A few versions ago, in some adjustments could only be made on this template here, but we changed all of them. Most of, or all of the configurations should be possible now within the builder pattern here. And yeah, this is no longer necessary to have that. So, and I want to give this a short try just to give you an idea how this behaves when we start it. So let's go to the no, not this application. Here we are. So let's run this. And I mean, it's always good to have an application like this for later look into this and see what's going on, and that gives you some ideas. So, and now after starting up the application, we should be able to see the different storages here. You see that here there are 1, 2, 3, 4, 5. There is one storage more than expected. So let's go through. The first one is the short storage. So it's called short storage, like this one here. And that brings me to the point to step into this. For the case you did not know what's going on your hard disk. So a storage consists of the channel folder. This is what I talked when we talking about multiple channels. So that means let's jump into, where do we have channel, the builder storage. It is called, how is it called? Is it path? Yeah, is it? No, it's not. Storage path, and path is, it's an environment variable. Okay, but yeah, you see that here. So when we have a look at this, you see multiple channels here, channel 0, 1, 2, 3. and every channel contains the same files. So that means the storage is split up into different channels, and that enables us to access from multiple threads at the end. Okay, so there is another file, which is an important one, the persistence type dictionary. Maybe during the training, we will get into this type dictionary. I would say, except from the data itself, this type dictionary is the most important dictionary or file of the storage itself. It has all the object type mapping in it. So every object that is stored in the storage has an object type and an object type ID, sorry, and then let's say an object type ID and object ID, I guess. Yes, and this is where the mapping happens. So in that file. So without that file, you will no longer be able to access your storage because it's just a bunch of bytes somewhere. Yeah, you will not be able to read this. Okay, so all the storages are created, and on top of that, some of them creates a backup storage. So for example, this one here, that builder pattern here, there is one line set backup directory, and that creates the path backup here. You see that? That's the backup here, and it should be the same storage like this one here. You see, this is equals. That means this is kind of like a mirror. So I will come to this also at the end of the training, how to write a backup like this. But this is a mirror written here. Whenever you access to the storage, a mirror will be written somewhere, and that could also be on maybe AWS S3, for example. So it's totally on you where to write down a mirror like this. But yeah, this is how it basically works, multiple different ways to initialize. And that brings me to the next example. EclipseStore could also be used not only on file system or on persistent volume for Kubernetes, for example, or for Docker. It could also be used storage an S3 bucket, for example. So, and therefore, there's also a project I brought you. So, just a second. Search for S3 store target. It's there. So this is the link to the S3 storage, and I prepared that example down here. It's also updated to version 3. And just to have a look into the DB class, nothing special in it here. There is the storage itself has kind of like an S3 connection. So this is the file system that is created based on AWS S3 bucket. And I also, when we jump into the bucket, we will see that the result is empty. So you see that this is my AWS bucket, and bucket is empty so far. And when we now started that application, so right-click, run as Java application. So application up and running, and there should be one. Yeah, there's a create books. So let's do so. Let's call the localhost 8080/create. Oh, books /create, I guess. So let's see the storage. It tells us a book successfully created. When we now have a look to the AWS container, to the bucket, we should see that when we refresh it, yeah, we see that the same files, it's the same bucket here, and we see the channel 0 and the persistence type dictionary here. And data should also be there. Let's do it like this, that makes it easier. Okay, so when we now call the just the books file. You see around 1,000 books were created on that create method. So that's all what now within my AWS folder. And when we stop the application and start it again, we should see that the startup time, so accessing the storage, is slightly more because the data has to be transferred from S3 bucket to the storage. It takes longer than normal, of course, but here is the data. And at that moment, when we now here, in that moment, it doesn't matter anymore if the data comes from a bucket, from a remote bucket, because we are in memory solution. That means as long as the data is in memory, it doesn't matter if the data is on S3 bucket. Except when we're talking about storing data. Storing needs a little bit more time, of course, because of the transport layer between AWS and the application itself. But yeah, this is working for for best practices. From my experience, I would always recommend using file storage because it's the fastest way. But we are always using, or mostly we are using a situation where we having the primary storage on a separated persistent volume. Then we have the mirror is written to a second persistent volume, and there is a full backup that goes to an AWS S3 bucket, for example. This is the way how we secure applications normally. And that works really great, in my opinion. Yeah, feel free to check it out. The application itself works out of the box. You just have to ensure that you have the secrets in place to access your AWS S3 bucket. And as far as I know, there are behind within an environment variable, then you could enter your own secret key and access key, and therefore it enables you to access. And last but not least, I created another example, and this is at the same time, it's the GigaMap example, because it's, and I also want to share this with you because it's an on-top configuration that is also working. I always need to search for it. Yes, here it is. Yeah, and this is another example, and we will have a way more detailed look a little bit later to that example, but I just want to share with you how to use it in a right way in combination with an microservice framework. And therefore, there are some different classes and packages and so on, not that important for now, but to understand how it works, there is one application property file here that has all the configuration in it. And then on top of this, we are using the Micronaut integration, which is available. So here we are. So when we have a look into the POM XML, we see there are two interesting. Here it is. It's Micronaut EclipseStore. It's also available via the launcher. But the current version of the original one is quite lower than the EclipseStore version for now. They need to update this, and therefore I added all my own dependencies up here to override the existing one. And normally you just you will need these two here, the storage embedded and embedded configuration. But on top of that, and within that example, I used the Lucene index and also the GigaMap, and therefore I added some more dependencies. But the basic approach is just use the Micronaut EclipseStore package and EclipseStore annotations, and that's all you need. And then you need your properties here. And after that, you will able to use it directly out of the box. That means let's jump into our data access object. So this is kind of like a repository. And inside that repository, you will be able to inject your root provider that provides you access to your root object. And you could inject the storage manager here directly. And then no DB class anymore, nothing, no manual or static initializing anymore. It's just directly working out of the box within the microservice framework. And as I said, I will come into, we will jump into that example a little bit later in a more detailed way, but it's just an example how to initialize EclipseStore basically. And that closes the topic of the different configurations. There is one example that I like to share with you. It's regarding the housekeeping. But this is next topic. I just want to jump into your questions first. But I always see it in my side eye here. There are a lot of stuff going on, and I'm a little bit afraid that I'm not able to answer all of that because it's so much text here. The common implementation is to bundle the images together with the application. Exactly. Or for advanced students, it should be better to have dedicated instances of just the EclipseStore and consume the data. Yeah, exactly. That's one question from Enrique. He asks what the best practice approach is. Yeah, I think it's totally on you. If you need a small storage inside an existing application and you want to keep it as simple as possible, just to provide it to someone, maybe a fat client application or whatever, then just add it as a storage. You could also use EclipseStore for testing purposes, for a testing database, for mock data, whatever you want to use it, do it. And if you want to go further, and if you want to provide the data, use it as a microservice storage framework till the current situation with EclipseStore and what we used it a lot, especially for migration projects. We started to use EclipseStore in between the database and the application itself as a cache to accelerate access to the data. And more people notice that having a cache in between, which is unable to store data at the same time, then the database is more or less just a backup at the end. And that brings me to the point where we can cut out pieces of your database monolithic part later and then split up your database into smaller, let's call it chunks of data providers. And that is the point where your database is becoming more and more a microservice storage cluster, or let's call it a sharded thing. So you shard things and migrate away from such monolithic big databases anymore. And it's not always necessary doing that. So if you have data which is not required to be available in such a performance, then keep it on your database. Feel free to have it there. And because memory might be expensive, so just use it for the data that is needed in high speed and in memory, then use it like this. It's on you. Okay. So feel free to use it whatever you want. So we are having this on many big applications within by several customers. So it's working for years now, so without any problems. Yeah, one interesting question: if our complete object graph doesn't fit in RAM, does EclipseStore swap data in and out? Yes, with the lazy functionality, yes. It's, yeah, as I said, unfortunately, it's not part of the advanced training now because it's more the fundamental training. And there is whenever you say, I can give you one small example. So let's say just an example we have here, a book entity, and maybe it makes sense to have the author loaded the lazy way. So that means you just want to stream through your books, but when you load a book, the authors should stay always on the hard disk. Then you just have to add something like this. It's a lazy wrapper, and then you could say author, and then it looks like this. So when you add something like this, then your author data stays on your hard disk as long as it's needed. So, but you should always keep in mind that when you, let's say we are able to, say having 1 terabytes of data running on an 8 gigabytes memory server, for example. This will be possible. Then let's say 95% of the data is handled the lazy way and stays on the hard disk. The more concurrent users are working on your system, the more data will be loaded. That's for sure. And you should always keep in mind, lazy loading is great. But if that data is needed anyway, all the time for all the users, then it doesn't make sense to have it loaded lazily way. Okay, I think that's really straightforward. But yeah, you could do this. It's more about what about binary data, for example. Does it make sense to have binary data in memory? Maybe yes, maybe not, maybe no. But then binary data needs to be lazy loaded or archive data, whatever, many different possibilities. Just to give you an idea at this point, storage, storing data, is that eager store? No, it's not loading data. So here we are, lazy loading. So this is the part of the documentation, and I will also share the link with you. So when you can find everything regarding lazy loading and how to use it, how to release data at the end, or how data is automatically released after it's loaded, and so on. A lot of things to know here. This is the link to that page. Okay. So let me move on. How much RAM does our need for best performance? That's an interesting question. How can we figure out how much RAM does our application need for best performance? I think there are no tools necessary doing that. As long as the data fits to your RAM, you will always get the power of your RAM, the calculation power of your RAM, and this is insane. So as long as the data fits into your memory, then you are good to go and you will get always the best performance on this. I would say there is no tool, but feel free to use any other tools for monitoring your systems like Prometheus or Grafana or Dynatrace, whatever. So these tools will help you to analyze your performance. And as long as the memory fits to the RAM, you will always get the best performance. Then EclipseStore works like a cache. So that's exactly the point. Cache is always fast because it's pure RAM power, and that's the same on EclipseStore. Okay, hope I answered everything that I could. Then what is, I built an example using a GigaMap with 150K records, about 2.7 gigabytes of data. And even with the machine had 12 gigabytes of RAM, the app didn't finalize the EclipseStore startup process and crashes. Oh, okay, then something must be wrong within your project. So first, maybe you should give it a try with a new GigaMap, but in my experience, I have way more data within EclipseStore, and without the GigaMap, we need to check this. Something must be wrong there. Because the GigaMap itself, the GigaMap doesn't care about data, how much data it is, because everything what's inside the GigaMap is always handled the lazy way. So at startup time, the data is not loaded. The reason for crashing must be somewhere else. So because everything is loaded the lazy way, till that moment you access the GigaMap, and then the GigaMap handles all the lazy and release data automatically in the background. Okay, so let's move on. Okay, so what is the next topic? I think it was the advanced storing mechanisms that EclipseStore provides. So therefore, I used next project. It's the CRUD project, and there is one controller here. It's a book controller. Oh, just a second. I forgot a topic in between. So yeah, one moment. Switch to, where is it? Exception. No, it's configuration. And then we need, oh, come on, here we are. Okay, housekeeping example. Yeah, that's one example I want to go first because it's part of the configuration. And it's the housekeeping. And sometimes housekeeping is quite important because with a more and more growing database, we have to take care about the housekeeping process in the background. So, and it depends. Oh, I destroyed something. Mockup users. Oh. What's happened? Okay, now we are good to go, right? So housekeeping example. Okay, so so let's jump into the project itself. There is one controller and it's a create books, right? And that creates a lot of books. So that means in that application, there is a mockup data here and it provides books. And these books are around 1,000 books here. And when we call that create books, it iterates 10 times through it and creates, let's say, 10,000 books. Okay, so this is what happens here when we calling the create books. And we want to see what's going on the storage side when we are using it this way. So it's at the one hand, it's a possibility to show you what housekeeping is for. And it's another point to show you what is the best practice approach storing things within EclipseStore. So you see, we are iterating through all the books, and on each book we say, give me the collection here and add book, and then we are storing directly after adding this to the collection. So this is what happens. So, and when we open this, we should see, oh, these things are not shown in System Explorer. So I need to clean up this a little bit. Okay, so storages are deleted, so I could refresh it here. Okay, so let's start the application. By the way, this project is already shared with you. And application here, so run it, and one moment, I need to do a maybe an update first. Okay. As Java application. So on my second screen, I'm starting the creation of the data. And at the same time, I want to show you directly what happened on your hard disk. So let's call localhost 8080 books create. So it creates now, and when we go to the data here, oh, come on. We need to be fast. Okay, we were not fast enough, but you see, there are inside our channel, we see that a growing amount of such channel files here. You see that? So we have channel from, or that are files. I would say each EclipseStore is working in the background as an attaching storage. Everything that happens on the storage will be attached to the storage. And let's say you are storing one object 10 times, then this object will be attached 10 times to the storage. And therefore we need a housekeeping process that cleans up all the data during the storage, the storing process. And this is exactly what happened here. If we writing data in a high frequently way, so like I did, so then the default housekeeping memory consumption and time is not enough to working properly, and therefore we are able to adjust this a little bit. So let's stop it, and I prepared this within that MicroStream XML file, and there are two different settings that could be done here. Okay. So let's do it this way, manual way. Okay, so the housekeeping interval, it is the interval between the when the housekeeping is started, and then the time budget, how long could it take to do housekeeping, or and that's interesting. When we now delete the storage and we start the example again, so we should see a totally different behavior of the application. So let me start this again. Run as Java application. So now we need to see the data folder here. And then when I now call the create method again, so then we should see that, you see now the housekeeping is powerful enough to handle storing such data in the background. And then you see it took us around, let's say, 3 or 4 seconds now to store these 10,000 rows of data within the storage itself. So this is quite interesting, because sometimes you have to adjust this. Normally the default behavior is okay, and it's, by the way, also on you how this how the storage behave, because instead of we could do it the same way. Instead of storing the data directly after editing it, we could also do it this way. So let's say not doing this within the for each here. So let's do this after. So that means when all the data is added, then let's store this all at once, not only one. And you will see the differences are incredible, because yeah, give it a try. So let's start it again. You don't need this. Yeah. Application here. Okay. Run as Java application. So I want just to share this with you. So I'm just pressing refresh all the time. So see that? So this is what happened when I click on refresh. You see the differences here? It's insane what the difference is between storing after each entrance of a book, I have to say. And this is that gives you an idea when it is important to increase housekeeping, or it is better to adjust your Java code to make it more efficient storing things. And normally it takes us 3 to 5 seconds by storing it directly within the for each, or it took us, let's say, half a second for storing the same amount of data 10,000 times. And now we should have around, I've clicked 10 or 15 times. Now we should have more than 100,000 rows of data within the storage. let's give it a try to load all of them. So this is what my browser acts. So yeah, and we should see a lot of data now. So I don't know how much data it is, but it is a lot. So yeah, that gives you an idea of good code, I have to say, or good implementation of storing things with an additional knowledge regarding the housekeeping and what the housekeeping does. So keep in mind, there is a possibility of adding such housekeeping. And this is not only when storing data, it's all about removing old entries or old storage stuff. And it decreases, by the way, also the memory consumption on your hard disk also from time to time. So the more that your data grows, the more it makes sense to increase the housekeeping. Feel free to adjust this like you does. So there is no sweet spot, I have to say. Just do it what it depends a lot on your data, I have to say. Okay. One question, is it possible to manipulate data without the application? No, not really. It's because the data itself is in a non-readable format. So without the application, it will not be able to access the data. So this is there are some tools on our side for data rescuing and stuff if something goes wrong, but it's not what we provide now to you. So you will need the application to see what's going on, because you have to keep in mind that your application provides the data structure, and without the data structure, without the knowledge of objects and how the objects belongs together and all the object relations, you will not be able to extract the data anymore. Can the stateful storage behind data grid be configured the same way? Yeah, that's an interesting question. I would say basically yes, in a way, not fully, but in a way. And the question if it's really necessary. When we're talking about the on-premises solution, then I'm pretty sure we will be able doing a lot of different things. Because mostly when we talk about on-premise, that comes with our support for our customers. So we will set up the on-premise solution together with our customer, because there is a lot of stuff that needs to be done. So a lot of adjustments within Kubernetes and Helm charts and so on. And it makes totally sense doing this together and to make it successfully. That's one part. And at the same time, when we're talking about this, we are able doing a lot of different configurations and make it happen to your needs, I have to say. But when we're talking about the SaaS solution is ready, provide for you. There is no big place for adjustments. You could adjust a lot, but it's working like it's working best on Kubernetes and persistent volumes and so on. Okay, so we already answered this. So how do we manage changes in the data entries, like adding or removing properties? This is a topic I've come a little to that a little bit later, but to answer this in short, this is managed mostly automatically in the background. You don't have to take care about this, but I will come to this. Okay, so guess we are good to go. Okay, so as I promised, we directly start into the GigaMap handling and the GigaMap examples. And before I go into this, as always, I have to share this with you. And that's the link to the project. And to understand what is the reason for why we invented the GigaMap, or what is the idea behind, you have to understand the, let's call it the pain points of EclipseStore in the past, and what was difficult to handle, I have to say. Let's start with a first example. So let's say we need to store a list of books. This is the step 1 here. And there are so many books that we can't have all of them within the storage. So for now, so as you see here, this is a list of books. That's okay. It's in memory all the time. No issues on that. It's possible to handle such an amount of books by splitting up the book, for example. That could be a solution. Let's say we have the most important part of a book, or the header, let's call it, header fields, whatever you want to search for or whatever could be part of that list. And then there is another list, for example, which is lazy handled and linked via let's say, let's call it foreign key or primary key, whatever, then this could be handled also. So, but the detail set is loaded the lazy way. That could be one solution to handle this. Another solution could be, let's add step 2. So the idea was how to handle it. Let's do it the lazy way. So let's say, let's wrap the list of book here within that lazy. And that means these books are, or these books staying at the hard disk as long as someone search through. And that's exactly the point where it is not working again, because when we're talking about Java streams, then at that moment we are calling books to.stream, then this whole collection will be loaded into the RAM. And then we are faced the same problem again, that we need enough RAM to handle this, and so on. So, I mean, you see the point on this. Lazy loading is great. Using lazy loading this way is not the best idea. But at this moment, there are always solutions, and that brings me to step number 3. So that means we have 2 issues here. We need to handle such amount of data, for example. At the same time, we need to search through. And that is kind of like a problem. At one time, we need to load data to read the fields and so on, to search within the fields. That means we need to load it to do querying. But on the other hand, we don't want to load it because the data is so heavyweight that we can't have it within the RAM. You have the same situation, or kind of like the same situation, when we're talking about relational databases. It's the same. You need to search through the data. I mean, that's an easy task, right? So you're writing an SQL on your application server side, and then for you as a developer, it's easier. Mostly you say, just load the data that is needed, and therefore we need a query. But on the other side, on the database side, you need to load the data and you need to analyze the data on the database side. So that means you need RAM twice on your application server and on the database side. And this is a point where most of you are not aware of when we're talking about in-memory technologies, because when you summarize the database memory RAM that is needed to search within your data, summarized to the RAM that is needed on your application server side, then you will have a lot of RAM for in-memory technology. But you understand the point. We need to search through, but we need at the same time handle the RAM. And that brings us to step number 3. So the idea is, why not using maps, for example, having the same structure, but with kind of like an index, right? So the string here, the key works like an index, and that separates the book. So that means we could use here at this point the very first 4 digits of the ISBN as an index example, that keeps the list here small enough to first go through the ISBN, just loading chunks of books, and then searching more detailed through the lazy lists of book here. So that is working and working really well, I have to say. But it makes the data structure more complicated, right? So to handle this, and that was exactly a mix of problems that we have here. The complexity of the data model, searching through, and having an index based to search through. And there is another aspect when we're talking about that index here. It's always an on-heap memory, right? So when all the fields that you want to search through, let's say there is titles of books here, for example, could also be part of that string here to search through. But this data is in memory, of course, but it needs to be searched through, and it's on heap. And that will go, or that will end up memory exception or out of memory, whatever. So, and that was exactly the 3 steps that brings us to the point. So that means we need a collection that is basically lazy loaded and manages the lazy loading and releasing data in the background automatically. So that's the first point. So that is what the GigaMap does. The GigaMap does need its own index. So there needs to be a point that we could create indices or indexes on that GigaMap. And these indexes needs to be off heap. So that means that could be an insane amount of memory within the index, and it stays off heap. That means the operating system is able to swap data or swap RAM to your hard disk. So you will not get an out of memory anymore. So that was the second idea. So lazy loading handling chunk-wise automatically in the background, and an index that can be created based on that. And this is exactly what the GigaMap is. So, and that is the story behind the GigaMap and why we created it this way. And let's get into this. So let me just show you how it works. And at the same time, it minimizes the complexity of things, because it's working like a normal collection with slightly more effort, of course, but the complexity is the same. Okay, let's go into it. We have our root object. It's the same like all the time. So we need to initialize the GigaMap itself. And the next step we see here is at that time, and that could be handled in many different ways, is to define the indexes or the indices that we want to have. And there are 2 of them currently available. The first is a normal bitmap index, a bitmap index. And the second one is a Lucene index that can be added. One restriction is you can only search within one index at a time. So it's not possible to search through, let's say, the Lucene index and then adding an end command after it. That is not possible. So you have to search within your bitmap indices or within the Lucene index. That's on you. And let's get into these indices. So when we now jump into the book indices, that's the place where the indices are initialized here. So I created a separated class just to configure my indices here. So there is an ISBN index, and it's a normal indexer. There is another one which is called binary indexer. The binary indexer is one index for a more, what is the right word for it? So if you have multiple, or if you have a unique index, then it makes more sense to use the binary index for a high cardinality, right? To having data which is a lot of unique data in it. Then it makes more sense to use the binary indexer because it's a more powerful and faster index. for normal things, so for example, for that ISBN, we could use also the binary indexer, but it's also okay to use this one here. You could also use the binary index for a string like the title, but I created another one here. I registered a Lucene index. That is how the Lucene index is created. By the way, I can show you the example documentation here. So when you go to the EclipseStore documentation, you see here the GigaMap. It's the new version of the GigaMap itself. There is a getting started tutorial here for indexing, bitmap index, all the explanation that is needed to know what's going on. And here is also the Lucene index and how to create an index like this. It's well documented here on that page. And I did the same here. I registered, or this is the method to register the Lucene index. And there is another index here for the release date. So it doesn't matter if it's a date or a string or a double, whatever. You could index every single element. You could see this here. There is an index for string, an index for Boolean, byte, character, date time, double. Any other Java-based data type can be indexed here. And it's totally on you. The most important thing is that in my case, we are just talking about books, right? So a book consists of ISBN, title, a release date, and there is some other informations like price and author, for example. In my case, I just want to search for ISBN, title, and release. I don't want to search for price or author. That's not important for me. Later, when we are getting the result, so let's say if we're getting a result based on, let's say, 1,000 books, for example, then I could go on with the Streams API and search for a specific price or whatever. So that means at the beginning, I'm creating an index based on these three fields here. And this is exactly what happens here. So I added one index based on the ISBN, one based on the publishing date or the release date index. As I said, Lucene index. And last but not least, that's an important step. I need one identifier index. It's kind of like a primary key index. That's an important one. And in my case, it's the ISBN index. Okay, so these indexes are created. The GigaMap is here, and that's all you need. When we now jump into the data access object to give an idea how the querying works now, then we are here. So there is a special API that is created. So let's say when we go to the Lucene stuff here, we are using the pure Lucene API. So that means when we're searching for something within the title, then we are using the normal Lucene query API. To be honest, I'm not an expert in that. I've used the same like in the example. But feel free to do whatever you want within that Lucene index. And it's the same on searching for an ISBN, for example. And here it's the API is also quite well. So it starts with the index itself, the ISBN index in that case. And then it has all the fields that are needed to search within. So let's say contains, in, index, is, not, and so on. It's a whole query API with and or and so on. And you could search with it. That it's totally on you to use this the right way. So yeah, and that's exactly what it is. So when we now I created that example based on authors and books, and there are some mockup utils to load that data. When I jump in, these are all that different books, and so do not need this anymore. There are some shutdown and startup event listener in that project. The trade data transfer objects. Let's jump into the controller class. Count books, page limits, and so on. All that stuff that is not really EclipseStore related stuff, but yeah, let's give it a try. Let's start it. And here at this, I want to start it with, so currently I need to start it. There are two smaller workarounds in that project. The first one, I want to share this with you because maybe when you're using it, you want to use the Lucene index, that you might struggle with that. There is, where is it? The DAO method. DAO books. Found books. Yeah, insert. Here we are. So that is the way how to store things. It works mostly in the same way with the normal collections. So that means you could always call the same manager.store, and then you will hand over the gigabooks as you are used to use. But it's also the possibility to use the store method that is directly attached to the gigabooks or to the gigamap itself. And there is one important thing now, it's you need to close the Lucene index after creation. So whenever you add something to the index, or let's say, whenever EclipseStore adds something to the index, you have to close the index manually. So it's just a workaround, and with the next upcoming version, this will be fixed. Just to let you know, the index will be written down to your hard disk, and you have to close the writer, otherwise the index will not be there. Okay, so let's give it a try. Let's and another one. It's the new version is not available on Micronaut, and that's why we first need a Micronaut update. But no worries on that. I already showed this to you. Use just a structure like this. Add all your dependencies here above, and then you could use the normal EclipseStore, and then it overrides all the smaller or the lower versions of the Micronaut integration because it's not there for now. And that forces me to start that application via terminal. So I will go on to show in terminal, and then I will start the application. So let me just double check if there is a storage. Yeah, you see that here. In that example, the storage is within the target because I started directly from the terminal, and there is the Lucene index, which is written also to the target folder. But this is okay to have it here. Just delete it. We do not need it at first start. And that brings me to the point to call maven mn run. And I also prepared a small Postman API for this example. Just a second. Don't need this anymore. Count books. This is needed. Then search by title makes sense. And yeah, okay, I think that's okay. Some others, I will call it via browser. So the server is up and running, and on localhost 8080, I guess. 8080, okay. So when we now call the first thing here, count books, we should get back 0 because there are no books in it. And then I have to call the create books outside Postman because I did not create an endpoint for that. So therefore I call localhost 8080 books create underscore all. Let me just check underscore all. No, it's not working as expected. So just a second. Create books, create all. Gigabooks. Okay, that was. So, and it creates, I guess, 1000 books. at a time. So it's done, already done. So let's just call some of them books, and there is one call which is called page, and let's call that 1,000 that I created for now. So one important thing you need to know is that the GigaMap never is not able currently to return all of the data. So you always have to page data when you want to access this, because yeah, it totally makes sense. We are talking about millions of rows, and it doesn't make sense to do that classic, let's say, select star or select everything from things. So that's why we provide that page functionality. And you see currently when we count that, should work like this. So there are 1,000 books in it. So let's create some more. So create all, another one, another one, another one, another one. So let's create, let's say 20,000, or let's see how it works. Count. Now we have 23,000 books in it. That's okay. And let's stop the application. So just to see if all the books are stored, and let's do it like this. Yes, stop it, and that's okay. So now we are able to start it again. And now we should see that all that books are still in place. Send this, and we get back the 23,000. One interesting thing would be to see the memory consumption. Now we should see that you see the startup is nearly zero, because all the books are stored the lazy way. There is no single book is inside the RAM, because it's as I said, it's managed internally. And at that moment, we're starting to search for a specific one, and that's why I want to use the Lucene index here. Just let me show when I call page 100. Let's search for a specific value here. Let's say there is one title here. Let's search for great. So it's Lucene is a full text search with a very powerful search, and let's say, okay, let's search for great. So, and see what happens. So, and this is the result. You see, it took us at the first few 300 milliseconds, because we need to load the data the lazy way. But so when we call it again and again, you see we're staying around at 9 milliseconds till the GigaMap releases the data at the end. So it's on you to manage this. How long does the data should stay in memory? The normal or the default value is if data stays untouched for, I guess, 30 minutes is the default, then it goes back to the database, and it could be adjusted. And at that moment, you reach 75% of your RAM. Then it releases all the no longer needed data. Okay, but you see, the result is, I don't know how many results do we get. It works really great, and it performs also really great. And the often we click it, the more how to say it, the request response time or the response time goes down, because of the JIT compiler, and Java modifies and optimizes the call, and that is really great performance, I have to say. And that's it. So it's GigaMap itself. It's a really powerful feature. And now the question is, do you need to use the GigaMap all the time? No, you don't. It's as I explained, it's only for these situations where not all the data can be stored in memory. And feel free to use normal collections like lists and maps. Feel free to use whatever you want. It's a great opportunity to handle huge amount of data within the RAM. Give it a try it out. it's we released the let's say stable version a few weeks ago, and I think it's a real powerful feature. Were you able to try it out? So is there someone who tried it out during my explanation? And does it work? That's more important. Okay, and does it work on your side? Hopefully. Not quite. Okay, what is the issue? So so maybe during that time I'm, of course, do so.
Hi, Christian.
Hi.
Can you hear me?
Yeah, of course I do.
Yeah. So, I'm doing some experiments with the GigaMap, and one thing that I stumbled off is that as the data, the size of data growth,
Yeah.
the use of memory on the machine growth as well. And
Okay. Of
by
course.
my experiment, I am trying to load about 67 million of records,
Okay.
and I was able to load about 100,000, and I have it gives some about 2 giga of the size of data,
Yeah.
gigabytes,
Okay.
and the machine has 12 giga of memory, and still the
Okay.
application was not able to start up.
Okay. Understand. Okay. You was the guy who asks
Yes.
at the beginning directly. Okay. Um, I'm afraid I need to get more detail into your project. Is it maybe you can contact me after the training directly via mail? Then we could have a look together on your project and find out
Okay.
what's wrong on this. I mean, sometimes it's just a small thing that needs to be adjusted, and there are always room for improve things. Let's have a look on this. So feel free to contact me after. So then we will have a look together. And it's
Sure.
also a great feedback to us to improve things, of course. So if there are any problems, let us know. That's important that we could work on. I mean, there are so many different use cases on the market that we are not able to test every one of it. So feel free to give us an idea what could be improved. So I think that's an important point on that.
Christian,
Yeah.
maybe one hint for the participant. It's always the case. So you always need more memory, more RAM than disk space, and it's because of to create and manage Java objects by the JVM. There is an overhead of metadata, for instance. So this is the reason why Java objects are always bigger than the equivalent amount of data on your disk, if this was the question. So there is always an overhead. You cannot avoid this because of Java. But we can reduce it. So if this is a huge problem with big data in memory, then we can use type handlers, and so we can reduce it by customizing.
This is also one of the this is also a powerful feature. I mean, the smallest step into such details is using the small int instead of the big integer object within your storage. If it's possible, that's important. It's not always possible doing that, but if it's possible to just use the small int, then the memory footprint is way less than the big integer, of course. And when we calculate it for, let's say, 1 million objects, for example, then this is a big impact on memory footprint. So that's one thing. And on top of this, there is a lot of improvements that could be made. There is as Marcus said, that special type handlers. So it's a one deep possibility to adjust or to create special type handlers for your needs that, let's say, halves the memory footprint to store things. But it's a big topic, and it's quite hard to explain it within a training. It makes more sense to do it via documentation, and documentation is there. Give it a try and see what you can do. And if there is something, let us know. So I have to say. Okay, some more questions regarding the GigaMap. I think the story behind is clear, and how to use it is clear. I shared the project with you. Give it a try it out, and let us know if everything works as expected. Yeah, exactly. Yeah. It's always a question if is it really needed to have terabytes of data, for example, within EclipseStore, within an in-memory technologies. So normally when I look at our projects with our customer, we have data in it for something between 40 and 120 gigabytes. I think that's the size range that we deal with currently, and this is working great. And yeah, it's all about the decision that needs to be made. What data should be used within an in-memory technology instead of using a relational database, for example. It's on you. So, okay, no questions so far. That brings me to the next topic, and it's the concurrency handling. Concurrency handling is a huge topic because we are operating, all sessions are operating on one big object graph. And to explain this a little bit more in detail, I prepared a presentation for you. And I want to get into this to make it more clear. What do we talk about when we're talking about concurrency? There we are. Here we are. Okay. So, concurrency handling. So lean back and enjoy. We have to clarify the different layers of concurrency. So what does it mean when we're talking about concurrencies, and what layers do we have? Then the question is, what is the differences between, let's say, a MySQL or relational database or any other database on the market, no matter what it is, compared to EclipseStore? Is it different, and why is it different? So, and also we have to clarify the question, is EclipseStore responsible to take care about concurrency? Maybe yes, maybe not. We will see. And then, more important, the possible steps to solve concurrent access. And that is a big question. And the interesting part on this is most of the developers are not used to deal with concurrencies. And that's a big issue because you don't have to, because the architecture of systems are so well made that it's, in a lot of parts, it's not necessary to deal with it. But let's talk about this a little bit later. So the first layer, or the first layer of concurrent is the technical concurrency handling. So that means on the Java side, so we have to deal with concurrent access to objects. And this, at the end, comes to a concurrent modification exception, for example. And we need, this is an important layer we need to take care of. And there is another one, which I called the business-related concurrency. And therefore, there is a quite famous example, and I provided it here to you. There is a customer, let's say ID 20, last name Doe, first name John. And the first user changes the last name from Doe to Baker. And the second user changed the first name from John to Mike. And guess what? User 1 stores the customer and user 2 stores the customer. And at the end, you will get a result that looks like this. So 20, Doe, and Mike. So this is yeah, as I said, a famous example. And most of the databases on the market handles such a behavior or covers that problem with optimistic lock or optimistic strategy or pessimistic lock. So that is okay. You will get it for free, right? So you don't have to deal with it. Okay, but there is another example which is also business related and which is not so popular, I have to say. So a car selling company, for example, only one car should have a 20% discount at a time. And let's go through this a little bit faster. User 1 calls, get discounted. User 2 calls, the get discounted car. In both cases, result car is 1. Then user 1 calls set discount car 2. Then car 2 is discounted. It's the same on user 2. And then both users calls remove discount cars. And user 2 also calls the remove discount car 1. And you see, this is a strange, this is a clear situation, right? But the question is, how is that situation covered from your side? It's business related. And that means most of the concurrent things on the business side are not covered by your database. So you always have to take care about yourself and based on your business logic. That's important. And therefore, the intention is when we're talking about concurrency, we're just talking about the technical concurrency. That is the layer we have to deal with and that we have to cover. And this is exactly the one that is the interesting one with EclipseStore. Because when we're talking about a relational database, for example, then we have mostly a structure like this. So that means we have a database somewhere here, then we have an application server in between, and we have the clients, right? So that is a 3-tier architecture, I would call it. And within that architecture, everything is separated within a session, right? So we have session A, B, C, whatever, and every client gets its own session. And therefore, no one has to deal with concurrency because it's handled by the session itself. And when it comes to the database, we are talking about single threading, and then we have our blocking stuff, and we have our database management system that prevents from concurrent access and blocks it, especially when we're talking about Hibernate and different sessions and so on. It's all managed by the system, so you don't have to take care about this. When we compare this to EclipseStore, it looks maybe the same. So EclipseStore, we have, so this is one case when we have EclipseStore within the application server as a storage technology. It's the same. We have different sessions, but at the moment the sessions are accessing the object graph. All the sessions will accessing the same graph, and that is the same when we have the same situation here. So we have a storage provider, some REST endpoints, like we did a few minutes before. Then we have an application server in between. We have different sessions, of course, but all that sessions accesses the same REST endpoints, and the endpoints itself and the sessions are accessing the same object graph. And that is the situation. We have to cover the object graph itself from concurrent issues when we working on this. And the question is how we could do this. Is that impossible doing that? And is EclipseStore responsible to take care about concurrency? I mean, basically every developer should be aware of concurrency. But the further question is EclipseStore able to doing things for you, and that is not the case. So it is a different, how to say, it's a different situation with EclipseStore you have to take care about, and EclipseStore cannot do this for you. So it's on yourself. You have to deal with that. Okay, so when we're searching for concurrency, we will getting thousands of different pages. And the interesting part is all of them are telling you, okay, there are some things you could do by handling concurrency, but best thing is at the end, prevent concurrent access. That's the outcome of every single page, because they provide you that information, because at that moment you deal with concurrency, it will always be a problem of performance. So it will decrease the performance. No matter what you are doing, it has a performance impact, or it could have a performance impact, so I have to say. Okay, and the possible steps to solve such concurrent issues, I want to show you, I want to share you with that directly within the IDE. And all the possible things that we could do came from Java itself, except one, so that we provide for you. And therefore, I created one project, which is called MicroStream Training Concurrency. Let me share this with you. So here we are. Okay, here is the link. So that's the following project. And this project consists of, or has also multiple branches here. And it goes from step 1 to 2 to 3 and so on. And I want to start at the master branch, just to give you an idea what the current situation is. So when we have a look to our book entity, so the first tier we have to start regarding concurrency is the field level. So the very first possibility to have this is, and that brings me to directly to the next branch. Wrong project. Here we are. Is using immutable objects. So that means when we have a look on book, for example, then we need to make the decision whether the ISBN could be changed in a book or not. So that's a big question. So can an ISBN change on a book? I would say no. And that brings us to the point where we could say, okay, let's make the ISBN final. That's the first step into making an object or making a field immutable. So it could not be changed. And whenever something could not be changed, it's automatically prevent from concurrent access, right? Because reading things is never a problem, but writing things is a problem. What about the name? Can a name change of a book? I would say no. It's not possible to change the name. At that moment, a book comes to market, the name stays forever. I mean, there are some different, there are some exceptions, but normally it would not change. The release date, can the release date be changed? No, I would say it's the same. Release date is release date. Do it so. What about the price? Yes, price can be changed. Therefore, we leave it as it is. But the author, what about the author? Can the author be changed? No. So So that's the first step, making things immutable. And this is, by the way, also a great thing when we're talking about records. So that's also the reason why records are invented, because most of the objects within Java can be immutable. The thing is it a good idea to store that price here that prevents being an object fully immutable? That has to be removed, right? So just add the price to a different object, or make a special table for pricing that, yeah, somehow belongs together, whatever, primary key, foreign key, whatever. Create a relation in between, and then it will work. And then your book is fully immutable. And then you could use a record instead. So that means use the final modifier as often as you can and create immutable objects. But now, at that moment, let's say the book now is fully immutable. How could we change something? Have you an idea? So this is sometimes it's people ask that. Okay, if everything is immutable, how to change something? I mean, the point is, you don't have to change it. Just create a new one and delete the old one. And then you see, okay, if I delete something, it's not an issue for someone, right? So deleting something is not a problem. So it could be, yeah, let's say locked or whatever. And it's in the same adding something, then we have we remove something, we add something, no problem within the book itself. And remember the business concurrency. So the John Doe example that I provide to you, this will no longer be possible when you have immutable objects, because you delete something, you add something, no problems at all. Okay, so that means use records and final whenever you can. First step, easy step, no additional work to do. Let's move on to the next step. And the next step is just a possibility, not really a recommendation. But I have to share this. That's, come on, again, the wrong project. Here we are. Using synchronized. Using synchronized. I need to find the right class. Here. This is really straightforward, right? So using synchronized is quite easy. We could use it on any method to prevent concurrent access to a method. Now, to be honest, I'm not synchronized. Could it be like this one? Oh, public synchronized, I guess, right? So that makes sense. So, but it doesn't matter, I guess. Okay, could be look like this. So feel free to use synchronized on method layer whenever you want. It's on you. And there is another aspect I want to share with you. This is possible. And when we jump into the root, this is also possible, because at the beginning we talked about the field layer or the field section. Now we have to talk about the object or collection layer, and we need to find a way to prevent a collection from concurrent access. And this could be also a solution. And I'm not sure if you were aware of creating synchronized array list this way. This is possible, and I want to show you an example of what happened if we do not use a collection the synchronized way. So this is maybe really interesting. Just give me a second. Switch to the master again. Discard all changes. So and normally I'm starting the project directly at the beginning to give an idea what we are talking about when we talk about concurrent issues. So, okay, application is up and running, and I just need to check if there is already data in it. So localhost 8080 create books, right? So, oh, great, we're getting an okay, I see. I need to do maybe an update first. So, okay. So let's give it another try, and let's hope that it will work. So let's say, okay. There is a storage already there with a different configuration. Now we are good to go. Okay, so we are now getting an empty result. So, and based on that, let's create some books. So I don't know how many books are created now, so it goes quite fast. I guess these are 10,000 or whatever. And there is one controller method here that is named iterate. So, and let's call this iterate here, books/iterate. So that leads to the situation that something is running through that that collection all the time. And what happens if we now call localhost/books/remove, I guess, right? Or delete book. So you see, you immediately you will get an exception, because at that moment you're reading all the time that collection. Someone tries to delete a book, and that leads to that famous concurrent modification exception. And this is one example why you need to take care about this. And that is the point also where it makes sense to having a collection like this. And it brings me back to the branch that we were when we talked about sorry, I don't care. So that we talked about within the was it storage data root here? Yeah, this one here. So to be honest, having a synchronized list like this makes totally sense when we're talking about, yeah, let's say smaller or medium-sized collections with less frequented values. That is totally okay using a collection like this way. Or let's say so the question is always how, what is the, let's say, missed the English word, so how,
Say it in Bavarian slang, I translate, Christian.
Wie hoch ist die Wahrscheinlichkeit? I can't say it in English. I don't know. The possibility that two people are having concurrent access is how obvious it is. Let's say it like this. And yeah, that's exactly the point. Maybe in less frequented collections, it's not necessary to do that, because accessing collections with EclipseStore is such a fast transaction that it's not necessary doing that. But on smaller and medium-sized, that could make sense, having a synchronized list. The problem on that is synchronized does not differ from read and write. Okay, so that means if multiple persons want to read through this collection, this will also be blocked because it do not differs from read and write. And therefore, we need to find the next better solution to accessing or to prevent from concurrent accesses. So that brings me to the next step. Using a really great technology, and this is at the beginning. Let's start with step 3. There are some different The new books. No, I don't want to go. Here we are. Okay, for example, the usage of a concurrent hash map, for example, and there is another one which is called, let me just check, it's in my presentation. Is it here? Yeah. There is the concurrent hash map, and there is another one. I can't remember the name all the time. Concurrent hash map, copy on write array list, and so on. These are all great solutions that can also be used for different purposes. So I mean, you have to go more in detail to see what it is made for. They all have their restrictions. You should not use it for huge amount of data, for example, or all that restrictions are, yeah, they're okay using it. But yeah, to be honest, there are much better solutions on the market instead of using the concurrent hash map or the copy on write array list. And that brings me directly to the next point and to the next branch. It's the copy, it's the reentrant read write lock. Let's jump to this. Switch to reentrant read write lock. Here we are. Okay, so the reentrant read write lock works a little bit more different, and it's an embedded, it's a basic Java feature. And in the past, we provided this as an example, but in the newest version of EclipseStore, we provide the same functionality within EclipseStore itself. That means when we jump into a data access object, you could always extend the data access object, extend log scope. And that log scope enables you to wrap every task within an add books, for example, as a write task. And at that moment, you wrap around this write, or read, for example, here, the framework, and the framework is able to handle that locking things and doing synchronized in a way automatically in the background. So whenever you want to access the storage, then you wrap it within the write. If you want to read it, just use the read. The big differences from the reentrant read write lock compared to synchronized is it differs reads from writes, and that's a big improvement, because this will handle, or this will provide you much better performance at the end. And based on that, you see there are a lot of things that could be done for handling concurrencies. To be honest, not every collection needs to be covered because that's what I explained. How possible is it to get a concurrent access to a collection? This has always be checked. But if you want to ensure a good system or a good behavior, you should be aware of that. So let's give it a try, right? So let's try to do the same with the reentrant read write lock. I just have to check if we, in that branch, if we have the same named create, iterate, delete. Exactly. So let's do so. Let's start it right away. As Java application. Looks good so far. Okay, so create books first. Create books are created. And now I iterate through. You see iteration is running here. And now we could try to delete something. So books, delete book. Now you see it's working exactly as expected. So no issues at all because of that reentrant read write lock. And in my opinion, it's quite easy to implement. Just use it on your repository methods to ensure everything is covered by concurrency. And that's the point where, in my opinion, it's not a big issue anymore to handle concurrencies. Okay, any questions from your side? Concurrency is more a Java-based topic, but it's important to be aware of because EclipseStore has these problems. Yeah, exactly, Milos. That could be. The problem is I'm not really an expert to Kotlin, and I'm not in this. Maybe my colleagues are. So I would appreciate it if you could provide something within our forum and that my colleagues can have a look on this. Maybe that will help. Okay, great. Some other questions. So let me get some coffee to staying alive. So during this is also needed. So let me check our progress. So that's also important. What topics do we need to cover now? So we talked about concurrency handling data structure, the GigaMap. So we talked about housekeeping. So we have LegacyTypeMapping left and backups left. And we have that storing advanced topics left. So we have 3 topics left: storing advanced, LegacyTypeMapping, and backups. So which one do you want to start? Choose one. It's to you. So therefore, how often is data synced to the storage? That's an interesting question. How often is data synced to the storage? Because the answer is data is never synced to the storage. So it's on you calling store. And whenever you call the store method, it is a blocking storing request to synchronize the storage. So whenever you call store, it will be transferred directly to the storage. There is no mechanism in the background that stores this automatically. Okay, so we have storing and legacy type. And legacy type has 2 thumbs up. So I will start with legacy type mapping. No worries, I will come to the storing. Okay, so let's close this because storing advanced is not that big topic, but it's an important one. I jump back to the CRUD demo because that demo contains that example I want to go into, and therefore I need to choose the right branch. And yeah, it's the master branch. We are directly here where we want to be. Yeah, okay, makes sense to me. When we're talking about storing things, and then we have to decide what store do we want to use. One moment, I missed my GitHub. I always need my GitHub repository beside me to know what code do I need to type. So okay. Controller here, controller down. Okay. Yes, okay. Let's get into it. Okay, let's say we want to change data or we want to change every book that starts with an A in the title. So let's start db.root dot get books dot stream dot filter, and b for book, b dot get name dot starts with an a, right? So this is what we want to have, and let's say for each, and then we use. Is it okay to use b again? Maybe. Yeah, let's do so. Okay, here we are. So we want to change every book that starts with an A. And let me copy this. That accelerates things a little bit. Okay, that is what we want to do. So we have some books. I don't know how many. And then after that, there is one question. So if the application goes down before the object is stored, then the object is lost. Yes, in a way. It's the same that I mean this that sounds problematic, but in the same way, the question is what happens if the connection between a relational database and an application server goes down at that moment you try to store something. Then you will get an exception, right? And it's the same in a way, it's the same on EclipseStore. But the difference between EclipseStore and the relational database connection is we are writing directly to your hard disk. That means the hard disk is part of your server. So the question is, what could go wrong in between that? Maybe, of course, maybe you are right. A persistent volume within a Kubernetes container could be detached or something like this. But normally, it's really the question, what could go wrong? There is no plug in between that could be. So if we have a problem on this, then we have a much bigger problem than just a connection issue. So, and then you should not recover the database anyway. So therefore, it is what it is, yes. Okay, so let's come back to this one. So let's stream through this, and then we have to say, okay, let's store this. Then I would say db.storagemanager.store. And remember, we have to store the object which has changed, right? So in that case, we changed the book. We changed or we modified a field of a specific book. And therefore, book is the reference holder of that field. And that's why we have to store B for book. Okay, so that's okay. So the point on this is, if you remember, I said storing something is a blocking operation. That means it's not the best way doing this, right? So because this will slow down the iteration of my stream here. It is much better for find something doing things like, yeah, it would be great to store the changed books at a time, right? If you have a collection here, something, or how to store it. So unfortunately, there is no collection. So we need to create the collection at the beginning, then stream through, then we will be able to store it. But this is that's not a good solution, right? So we need to find something else. And there is a possibility having that. And that brings me to the next thing. We could say db.storagemanager.create. And then we call that create. You see two methods here. One is the create eager storer, and another one is the create lazy storer. So what is the difference between eager and lazy storing? That's sometimes not easy to explain, but in easy words, I try it. Lazy storer, it's the default, by the way, it's the default behavior. It stores only the object which is handovered without any underlying or any attached sub-entities below. Let's say we have a book and an author, and you hand over that book. A lazy storer will only store the book itself. Why is that the default behavior? You remember, EclipseStore is an attaching storage, right? So now when we say we're talking about a huge object graph, for example, and then we want to store a book, and a book consists of author, address, street, country, whatever, and we would do eager storing all the time, that means all these objects below a book will all the time attached to the end of the storage. And that is not best practice, I have to say. And that is why lazy storing is the default behavior. So, and guess what? Eager storing is the complete opposite of that. So that means when we're using an eager storer, eager would store the whole object graph below a given object. So, right? So that's the basic explanation. There is one special case that is a little bit different. It's all about changing things. When we're creating things, let's say we have a book and it's a new one. Let's say we call it new book, for example, and on that new book, we adding an author, for example, and on that author, we adding an address maybe, and we add this, so we insert this to a collection. Then also the lazy storer will take care about the underlying sub elements, right? So except inserting things will be covered by the lazy storer. Okay, in our case, we will create a lazy storer because at the one side, it's the default behavior, and on the other side, we are just changing the price, and its price is a direct field of book. So it's okay for us to use the create lazy storer. And now the magic comes. When we use the lazy storer here, we could say lazy storer dot store, and now we could add B for book, right? So, and this is sometimes a little bit confusing because store tells you it will be stored, but this is not the case. Store is more a registration, right? A registration to be stored in the future. And this is exactly what happens then. At the end, when we say create lazystorer.commit, then this will really goes directly to the persistence. And this is the point where it becomes more kind of like a transactional behavior. So, so that means if something goes wrong here, it will not be stored to the hard disk, but we need to find a way to roll back that, right? Exactly. Because let's say something goes wrong here, then price is already changed, and we need a way to set back our changes. So this comes next to this. But I think that's an important part to know that functionality. So that enables you for having kind of like a transactional behavior. Okay, so let's move on to the next layer. It's the exception handling layer. So that means what if something goes wrong here? And that is another project I did not provide it to you so far. Let's call it exception. Okay. Exception handling, here it is. Okay. Okay, so exception handling. It contains, again, different branches and with different situations. I mean, all that projects are planned or made for doing a hands-on, and therefore there is always multiple branches to start with or to. And I want to jump into directly to the exception handling part here, and we should see a proper implemented way how to create a rollback mechanism. So the first step is this is our controller method for update multiple object, and as it should be, there are some filtered books here. For get the ISBN starts with 49, and I hand over those books to a repository that updates that multiple books for us. So, right, so that is how it should be. And then that brings us to the point here, update multi-books, implemented in the same way that we talked. So we created the lazy store, everything is all right. Okay, so just a second, I missed something. That's the wrong branch. Here it is. Okay, so now we are directly here. At that moment, something goes wrong. We could use the normal try-catch functionality of Java. So at that moment, something goes wrong here within the try. So we could go down and could do something kind of like of reloading stuff. So, and therefore, EclipseStore provides a class which is called Reloader. And the reloader could be created by .new, and then you have to hand over the persistence manager. So persistence manager is provided by storage manager, and you hand over this, and then you could create a reloader like this. And based on that reloader, the reloader provides you two methods. And one is the reload flat, and one is the reload deep. And the differences between those tools are the same differences like the lazy storer and the eager storer. So, and it works exactly the same. When we call reload deep, then all the elements below a specific given object will be rolled back. And that is that provides you in a way the same behavior like transactional behavior and commit and rollback stuff from a normal database, and that are you used to use normally. On top of that, there is one thing I want to mention, which is also really important. There is one situation you need to be aware of. When let's imagine we have one, we changing something on the storage, and you call a store, and something goes wrong for whatever reason, then you will get an exception in the log. Okay, that's okay. The user itself does not notice that because the RAM has changed, and if you did not implement it the right way, you will the user on the end will not notice that it has not been changed because the RAM is changed and it feels all right for the user. So that means user is working, going on and going on. So, and let's say this happens for 30 minutes. After 30 minutes, you notice, okay, something is wrong. And that means you have a lot of changes within your RAM, but it's not persisted at all. So that means, and this will lead to a huge amount of lost data, because after a restart, all the data is gone, what happened within the last 30 minutes. And this is important. That is the point where I explained before what could go wrong. So at that moment, something goes wrong during the store. Something really, really bad happened, I would say. And you should not try to recover the system at that moment that the store method returns an exception. You should immediately turn down your server because something really problematic happens, and you should solve it and prevent users from entering more data which is not stored at the end. And therefore, I provided you something like this to say, okay, we wrapped around a store method around the normal store to create a try-catch here to do something if something happens, and on storage failure, for example, then we are saying context. So storage manager is running, and then we're stopping the application and shut down the server, or shutting down the application and clearing the root, because at that moment you clear the root object, all the users will notice that data is gone and something is really wrong with the system. Okay, but this is, yeah, a dramatic situation, but just to let you know, you have to take care of this. This is part of the proper exception handling, I have to say. So knowing how to roll back data, knowing how to having transactional behavior and or covering exceptions within EclipseStore. Okay, so that was the more extended part of storing something and rollbacking stuff. It's also covered within our documentation. So there is a whole topic of reloading and rollbacking and so on. Any questions so far? I guess not. Yeah, it's later date. Yeah, for me and maybe for you as well. Okay, next topic. So yeah, we are jumping from one to another topic. Is legacy type mapping. So what happens if something changes in my data structure? Before we getting into this, I want to share with you the place where all the theoretical knowledge is placed, and especially for legacy type mapping, which is our strategy to handling changes within your classes. Then we are talking about automatic mapping, and there is one which is called the explicit mapping. To be honest, I've never used explicit mapping because it was not necessary doing that. And I will explain this to you a little bit later and how we use it the best practice way and how it is working for us and all the projects we are dealing with. For us, the automatic way is totally fine and is working for us since the last years, I have to say. But let's directly jump back, and I want to give you an idea how we could do this. But before, as always, I need to share the URL with you. So there is one project which is called LegacyTypeMapping. Yeah, here we are. That's the link. And of course, I'm prepared. I prepared an yeah, here it is, a small presentation, just to give you an idea how data is handled in the background. So this is the point where I promised you at the beginning. We will get into this. Oh, no. Oh, I clicked on the link. Okay. So how does EclipseStore handles data type? So this is exactly one part of a persistence type dictionary. Let me jump into this, or let's do this later. No problem. So this is a small piece of a persistent type dictionary file, and you see it always looks the same. There is a object type ID. This is the first one here is the type ID, and the type ID is mapped to the structure of a customer, for example. So that means a customer itself has an ID field, a last name field, and also the information of the data type and so on. So this is how the persistence type dictionary is hit. And when we now look at the storage itself, then every entry of the storage, so we are always talking about storing an object graph, but in reality, this is not the case. In reality, as I said, it's an appending storage, and it adds things at the end. And every entry consists of a type ID and an object ID. And this is how the storage works in the end. And now the question is, what if something changes in a class? So let's imagine we are adding things or we changing things within a customer class, for example. So the old one consists of ID, last name, first name, male, and gender. And the new one has some changes in it. So we changed, let me just check. Yeah, we added something. We added the IP address here. And that means at that moment when we starting an application with a changed class in it, our EclipseStore will immediately create a new type within the persistence type dictionary. So it looks like this. So there is immediately created a new one, but the storage itself stays untouched until an object is loaded. And that's why we are talking about our legacy type mapping is working kind of like a versioning. So that means at the beginning, when we invented that system, we planned to do it directly at startup at a time. But that, imagine we have gigabytes or terabytes of data maybe, and on startup, everything will be changed. This will take forever. So and then we decided, okay, let's do it so if data is loaded into memory and it's touched or it's handled within the storage, then it will be transferred to the new object. So that means during the time you will have old objects in your storage and new one. As long as these objects stays untouched, they will stay in the old version. And this is how it basically works from the technical perspective. So, but the more interesting question is, how does the application know what has changed and how to transfer from old to new? That's a more important question. And this is based on an automatic heuristic. So it guesses, I have to say, it guesses what could have happened. So that means based on the position within the Java class, based on the name, based on the data type, and some other things, our EclipseStore guesses what could have changed. And this is one example. So name to first name, he says, okay, it might be moved, for example. Last name is renamed. Email is renamed. Node, support node is renamed, and so on. So it guesses the changes. And this system works incredibly good. So it works so good that even if I tried to if I try on purpose to do something that could not be handled, it's quite hard for me doing so for the trainings and so on. It works great. And at the end, when we change something and when we start up the application, if you want, the application asks you, okay, let's see, I noticed something has changed within our classes. And he tells you what is the result, what is the guess, what could happen. And if you're okay with that, you could say, yes, it's exactly what I expected. Then you could click yes. And at that moment, EclipseStore knows how to handle old data types compared to new ones. Okay. But moment, just, yeah, I don't need this. Okay, what are the limits? Or let's have a look on this. I think it makes sense to see this live. Team switch to, yeah, let's go to the master. So we need to ensure that we have an empty storage. So we need to delete the old ones. Then we have to have a short look to the author. So author entity consists of male, first name, last name. And by the way, if there are changes, I would recommend not doing all the changes at once. So it makes sense for doing this step by step. That will make no difference at all. But it prevents the heuristic from doing for failing. It makes sense for not changing 20 fields at once. So, and I would say it's not the usual things we do, to be honest, especially when we're talking about an in production system. But yeah, it's a recommendation from my side. Just do it step by step. It makes more sense. But let's come back to the example. So male, first name, last name, and we need to start it, of course. So let's application. So I will do everything on my second screen. So So localhost, it's hopefully always the same author. I have to check it anyway. So create authors. Yeah, it's authors / create. Here we are. Okay, so the database is initialized and there is one author created. Let's check and I will share it with you. You see there is only one mail link, first name, last name, Charlotte link. Okay, so let's stop the application and let's move on to the next branch. So team switch to change stage 1. And now we see when we go into the author class, we see the changes. So when we compare it, so we see mail author is changed and renamed. It was mail before. First name and name is changed to last name. Okay, so that's now what happened if we restart the system now? And we should see exactly that screen that was also provided by. So at that moment when I call or when I initialize the storage, you see exactly this message here at the bottom, and you see author mail. This is the old one. It has a 70% of renaming to mail author, 100% first name because it stays the same, and last name and name has changed. And write yes to accept the mapping. Yes, do so, and everything is all right. And at that moment, when we have a look at that result that we get, we see it's directly changed. So it's called mail author instead of author, first name and name. So you see, this is working really great. And to be honest, we mostly doing the most of or the biggest changes are happened before productions, I have to say. I know sometimes there are big changes also in production, but this will help you out most of the time. But what are the limits of that system? Well, the limits are when we're talking about changing data types, for example. So transferring data from string to integer, from integer to string, whatever, all that heavyweight stuff. And the question is, what is the differences compared to any other database on the market? So we need to have data transfer. We need to have some business logic somewhere to migrate data from version 1 to version 2. It's always quite a mess doing that. And I would say it's the same on EclipseStore. When we are talking about such a thing, there are two possibilities. First one is using get methods and set methods to transfer data. Maybe this is one possibility. I personally do not like that solution. But maybe I have to do it more precisely. So when we're talking about such changes, then we usually creating a new field below the original ones or the old ones, a new field, and we adding some business logic within the get and set method to transfer the data during runtime. So that could be one solution. The biggest con on that is you will have that business logic forever in your project, and maybe that's not the best approach. The second one is we are doing the database transition in the background. So that means we updating the storage in the background, and then we are uploading the storage at the end, and then you have the new storage in place. So that there are multiple different things, strategies you can do, but the recommendation is doing this in the background, updating this, especially when it comes to such heavyweight changes within the database. And there is a third solution, but be honest, I have never used this before. There is a possibility to add some code within special EclipseStore type handlers. And these type handlers will transfer also the touched objects to the new version. It's kind of like the same of using get and set methods, but it's a mechanism behind the scenes that can also be used. To to be honest, I never used it. It's part of the documentation. It's up to you to see or to check this out. One special thing you might ask, okay, what if that heuristic is not working as expected? So that could be the case. Then I have to forward you to that part here in the documentation when it becomes to the explicit mapping. So it's always possible to use the explicit mapping. And that is also relatively easy to use a refactoring CSV file here to tell the storage, this is the old one, and that's the new one, right? So, and these are the changes. So first name is first name is going to last name, and email is going to email address, you know? So this is always possible to provide your own refactoring CSV file to make an explicit mapping. That's also the case. But this is, to be honest, I've never used this. I'm okay with the heuristic. It works really great. And if, to be honest, if you change 20 fields at once, it's quite obvious that you will get an error, maybe, but not guaranteed, I have to say. Okay, any questions regarding the legacy type mapping? Did I answer everything? Hopefully. What about automatic changes on server when you have access to logs but not to the terminal? How does one type Y? Okay. Yeah, that you are right. Having such a terminal here is a great thing when you're sitting in front of your computer and you're doing that. This can be disabled in the database here. So I enabled this explicitly for that example to not forget the feature. But let me just double check. Legacy type mapping and this one is it. A set legacy type mapping resulter. This part here enables the feature that is asking you for that. It's not by default included, but it helps you to see if everything is working as expected, and you could try it out before getting into production. And if it's working as expected, you will have, of course, you will have a backup of your storage, and then just start it up. And if it works before and it's the same storage, you could trust in that everything is all right. And EclipseStore will do its thing automatically in the background. So you do not have to confirm all the time. It's just for kind of like a developer, for developer tooling or whatever. Hope that answers your question. Okay. So there is one smaller topic left, and I promise that's the easiest topic of all of that we talked. But in some parts, it's also the greatest, because everyone is talking about how to back up things, right? So we need to create backups, and that is an important task. And therefore, I need to share you the last project for today. It's called Backup Strategies. Here it is. And surprise, it's not in my list. So why it is not there? Here it is. Okay, backup strategies. To make it clear directly upfront, it's there are two backup strategies included, and the third one is planned. So the first one is mirror, the second one is a full backup, and the third one is yeah, I would call it an incremental backup. So only the changes are backupped between different ones, but it's still work in progress, and we will see what happened when it's available. But let's talk about the more important ones that are already there. Okay, need to check if there is continuous backup done. Let's start with this one. Continuous backup. So I explained it a little bit before. It's a mirror that is written somewhere. So when we go to the DB class, we will see it directly here in the MicroStream XML file. It is configured and it's just this line of code. So there is a property backup directory, and you need to provide a directory to write the mirror in at that moment when you store something. That means every time you call a store to your main storage, it will also store it in a mirror. So that means you will have a direct mirror of your storage somewhere else. And that's the situation where I always prefer a second persistent volume. It could also be a persistent volume from a separated system, no matter what type of volume it is. It needs to be mounted to your container maybe, or whatever, and you're totally okay with that. So everything that could be mounted to your container can be used as a mirror volume. This mirror can also be an AWS S3 bucket, but as we know, it needs a little bit more because you have to transfer the data and so on. It's not the best choice, I have to say. Okay, so, and that's all you need. So that means when we start up that project here, with that, sorry, I need to do it first. Okay, now, application here. Now we are up and running. That's okay. Let's go to the book controller. There's one create. That's all we need. Localhost create. Oh, books create, right? Yeah. Books/create. Okay. So now books are there. So only 4, right? So, or less, even less. So these are the 4 books that I created, or just, no, 4. Okay. 4 books. And now when we have a look to the storage itself, so let's refresh it. You see there is data. And yeah, to be honest, that's not the smartest thing. I created the backup in the same folder than the main storage, but it is what it is. So you see, we have a persistence type dictionary here and the 4 channel. So that's the default settings of the storage in that project. So, and the backup is directly created in it, and it has the same 4 channels and a persistence type dictionary. So let's say something went wrong, whatever can go wrong. So let's delete. Is it, am I possible? No, I don't. So System Explorer. Let's do this on another screen. So I delete the original storage now. So now it's gone. So I will prove this to you. So you see it's gone. And now I copy the channels from just the backup directly to the storage itself. So here we are. So let me refresh this. Where is it? Here we are. Okay, you see, I copied from one to from the backup to the productive state, and now we should be able to start up the application again. So let's do so. So And let's refresh the data. And here we are, the same data again. This is really easy, right? So it's a mirror. It's written whenever you store something. It will be stored at the same time. You call the store method and then it goes to the mirror. That's the first stage of backupping something. The next stage is creating a full backup. So that means at that moment when you click on a button, it writes the whole storage to a different system. Let's move to the next branch. I'll switch to full backup done. And it's also quite an easy task. And in my case, we usually use a Quartz scheduler. And this is the task of that scheduler. And this is the only line of code you will need to create a full backup. It's a method that comes directly from EclipseStore, and it's really important that this backup is part of the normal storage threading system, because you have to ensure that you don't have half the data written to somewhere before the full backup comes and grabs the data and copies the data to somewhere else. And this is, by the way, the same problem with cloning something. I have to say, you will be able to clone things 100 times, and this will work 100 times, but 101 it will go wrong because of something is written or something, you're writing a bigger file or a bigger data set to your storage, and at that moment Kubernetes clones the pod or the volume and something goes wrong. So you should always use an internal mechanism to clone or to create a full backup. And yeah, as I said, it's on you how many backups you cover on that S3 bucket, for example, or whatever. Normally we're doing cycles like, deleting after 7 days, we are deleting the oldest ones and so on. This is extended business logic. It's totally up to you to handle that. As I said, in the future, there might be another backup, the incremental one. It's more to than to handle huge or big storages, terabyte storages maybe, that can be copied fully to another system. Therefore, in a more extended example is also part of the backup strategies here. When you go to the last branch here for, let's say, continuous backup S3, for example, then you will see a more extended version where the continuous backup is written to an AWS storage. This is quite fancy stuff, and therefore it's not that important because I do not use it this way that much, but it's possible, and it's, I would say it's worth to see this and to check this out. And I think this will cover most of your needs for backupping your database. Okay, that's all regarding the backupping stuff, and I think there are 10 minutes left so far, so it's enough time for your questions if there are any. And feel free to ask. There is one. I could directly answer. How would one update number of channels? Oh, well, give me just a second. How would one update number of channels since it says found channel 1 dot match the config? Okay. This is an error message, which is the one that tells you that that happens often in my examples because I created a storage on a different branch, and then I tried to use the same storage on another branch, and the settings are different. This is maybe an interesting thing, because there is okay, give me a second. There is where is it? I created a project especially for channel migration. This one is it. That's exactly what I'm looking for. There is a main method. So maybe that's interesting for you. And I told you that is the last project I want to share with you, but so you need to find it. Yeah. Another project. Just to want to let you know, this is an interesting code snippet here. There is an implemented change management, I would call it. So that means when we want to change the storage directory, the name of the storage directory, the channel count, and many other things could be handled with that update here. And it transfers the storage from different configurations, I have to say. And that could be quite useful. So it always works vice versa. So you could transfer it from 2 to 4 channels and in the other direction. That is quite interesting. It's not that worth it to show it within the training, but I created an example. This works quite well. Always, you should always have a backup, of course, in place. Sometimes you made some mistakes or whatever, then it's always good to have a backup. But this is working really great. It's just a small example in that main method to migrate a storage. Yeah, I have to say there is a lot more things within the API. Things that I not noticed so far. There is a lot of stuff ongoing, but for normal production, wait, it's totally enough to know that stuff. Yeah, some other questions. Okay, so let me jump into my list where we started today at 5, right? So just to prove that everything is covered within that training. So we started with a warm-up project with some CRUD operations. We talked about this. Then we talked about different ways to initialize the storage, multiple storage manager within a project. We talked about the Micronaut integration. Then we directly talked about housekeeping also. And then we moved after the break directly to the GigaMap and the GigaMap handling. And then we go through the concurrency handling to the storing advanced section, lazy storing, transactions, rollback, exception handling, to LegacyTypeMapping, and last but not least, our backup solution. So I'm pretty done for today from my side. But yeah, feel free to ask. So I'm still there, no problem. Question about storage. Is it smart to store things on disk since there's no network I/O, but backupping to S3 until I hit some limits on my server memory? Yeah, so I think that's the question regarding, do we have what is best practice, remote storages or having storage on my on the hard disk? At the end, I have to say it does not make really differences, because we always have to consider that EclipseStore is an in-memory technology, and it should be used as an in-memory technology. So it should be used as a cache or as a high-performance provider of data in the end. If you create a storage that where everything is lazy loaded, then yeah, it is maybe it's easier to implement and it's better for the developers. But at the end, yeah, of course, there is no OR mapping anymore, and it's faster than other systems, of course, but it's not the full performance. Therefore, the question is if it makes sense to use it all the time in a lazy way. It's an in-memory technology. Use it so it makes sense. But at the end, you should always consider that even if you use a remote storage, data will be in memory anyway. Only the lazy stuff is the stuff that takes a longer to load, not the lazy stuff that stays in memory. Okay, so that brings me to the end of that training for today. I want to say thank you for your attention. I hope it was interesting to you, and I would say try it out. It's a great technology, and it works great for me in my projects, and it will also work for you, I'm pretty sure. Thank you for your attention. Try it out. Give us feedback. That's important. And have a nice evening or day or whatever. Thank you. Enjoy.